Hi everyone. This project uses survey data to understand how students balance reading and screen time. The code takes machine input and prepares it for clustering using KMeans, a machine learning algorithm that groups similar data points together. Step 1 is data selection. So before data selection, we have import all the libraries in input OS, libraries like pandas, numpy, matplotlib that is used for matplot library used for plotting the graphs, scalar and matrix, and cluster, etc. etc. Then it comes to data selection, where to import the CSV file that is our main data set. Here the column names in the CSV file aren't consistent, so the code uses smart substring search to find the right ones, like book read past year, screen time, and binge frequency. This makes the code flexible and reusable. Then it comes to data cleaning. Some responses are missing or written in strange formats. We converted them to numeric values using PD to numeric function and fill any missing values with zero. This ensures the data is clean and won't cause error scatter. Then the step 3 is feature engineering. We created a new feature called reading to screen ratio. It calculated by dividing the number of books read by the hours spent watching movies or series. Like this gives us a clearer picture of each student's habits. The next step is processing pipeline. We separated the feature into numerical features like book count and screen time, categorical features like reading preferences and favorite genre. Then we used conm transformer to apply standard scalar for scaling the numerical data, and one hot encoder for converting categorical data into machine readable format. Sorry. And the next step is Windows specific fix. KMeans sometimes throws a thread related warning on Windows. To fix that, we set omp num threads to 1. Okay, that is here. Omp num threads to 1, which limits parallel threads and avoids the warning. And the final output is here. The result is a fully prepared dataset ready for clustering. From here, we can apply k-means and evaluate the quality of the clusters using metrics like Shillot score and Davis Baldwin score. That's it.
To understand these, first I have to understand what is inertia. Inertia is a sum of square distances between each point and its assigned cluster center. We are doing this using the elbow method. It is basically the method that helps us to find the ideal number of clusters by plotting the inertia against different values of k. So as k increases, inertia decreases. But after a certain point, the improvement becomes marginal. The elbow point in this graph is where the rate of decreases sharply slows down. That is our optimal k. So in this first part, in this for loop, we test k from 1 to 10. For each k, we feed a k-means model and record its inertia. And then we plot the inertia values to visualize the elbow. We can see in this graph that the rate of improvement slows down significantly at k equals to 3. This elbow point suggests that three clusters offer a good trade-off between accuracy and simplicity.
Hello everyone, I am Anirban Ghosh. So, alright, with our optimal number of cluster determined, we have executed the final stage of our analysis. Let's break down the result of you see here. First, we train our K-means model with an optimal K of 3. The output shows our model's performance matrices. A CLOT score of 0.279, which suggested our cluster responsibly distinct from each other, and a Davis-Bowlin index of 0.82 indicate good separation. The scatter plot provides our first clear visual. We can immediately see three distinct groups: clusters 0, 1, and 2. In cluster 0, this is our largest group representing the majority of students. They fall within a moderate range of both reading and screen time. Cluster 1, as blue X mark, this group is characterized by significantly higher screen time clustering towards the top of the plot. In cluster 2, yellow diamonds, this is a small but very distinct group. They are the outliers showing extremely high numbers of book read. The real insights come from the cluster archetypes and the heat map. The heat map is a visual summary of the numerical table above it. Let's analyze each cluster. In cluster 0, this is the balanced consumer group. The heat map and the table shows they have a moderate average of about 3 books read and 18 hours of screen time per week. They also have a low binge frequency and are the most likely to read fiction. In cluster 1, we can call this binge watcher cluster. The heat map clearly highlights a very high value of for screen time, averaging over 45 hours per week. This group also has the highest binge frequency at an average of 3.5 times per week. They are most screen focused students. And the last is cluster 2. This is our super reader archetypes. The heat map reveals an extremely high average of 45 books reads per year for this group. Their screen time is very low at around 10 hours a week and they rarely binge watch. Like cluster 0, their top genre is fiction. Finally, the cluster size at the bottom confirm our findings. Cluster 0 is the largest with 25 members. Cluster 1 has 11 and our unique super reader group cluster 2 contains 3 members. In conclusion, our KMeans model has successfully segmented the student population into three meaningful and distinct groups based on their media consumption habits. Thank you.